Now I am starting up with the sixth chapter of your book, which is factorization. Now, in this book, chapter, I mean to say, in this chapter, you have to find the remainder of the algebraic expressions, not by dividing, but by using the remainder theorem. In your lower classes, you used to do the division like this. For example, if I tell you to divide 4x cube minus 3x square plus 2x minus 4 to be divided by suppose x minus 2. This is, we call it as the long division method, which you have done it in your lower classes in algebra. Division by long method. But now in this chapter, you are going to find the remainder not by dividing the algebraic expressions by its divisor, but by using the theorem, which we call it as the remainder theorem. Now in the lower classes, you must have learned this also, that dividend is equal to, when you are asked to check whether your division is correct or not, dividend is equal to divisor into quotient plus remainder. This you must be knowing it. Now in this formula, if I put divisor as 0, then what your dividend will become? Dividend then will be equal to, as I am putting divisor as 0, 0 into quotient plus remainder. And 0 into quotient becomes 0. So dividend is equal to remainder. So dividend becomes the remainder. And dividend is what? The algebraic expression which is to be divided. So the algebraic expression which is to be divided becomes your remainder. This concept, we are also going to put the divisor as 0. And this concept will be used to find the remainder. Now you will be able to follow it if I take one of the question of this theorem. Suppose my question is to, using remainder theorem, find the remainder when 2x cube minus 3x square plus 7x minus 8 is divided by x minus 1. Find the remainder. So now you are not going to do by division method, using remainder theorem. So now whatever algebraic expression is given to you, which is a polynomial, you are going to first give a name to it. So you will say let fx is equal to, or you can also say, normally we use small letter, you can also say gx, small g, px. So this is an algebraic expression in terms of x. So let fx is equals to 2x cube minus 3x square plus 7x minus 8. Now whatever algebraic expression is given to you, you have to give a name, as I have given fx. Now see the steps what you have to do one after the other. While I was explaining you the theorem, I told you, if suppose divisor is 0. So what is your divisor? It is x minus 1. So to do it by the remainder theorem, we have to put the divisor as 0. From there you get the value of x. So now when you are going to put the value of x in this algebraic expression, or which we say the value of f1, in that case I told you the dividend becomes the remainder. So if you are going to put the value of x in your algebraic expression or your dividend, it will turn out to be the remainder. So now first thing you have to do is you have to suppose the polynomial. Then you are going to put your divisor as 0. From there you are going to get the value of x. Now you have to write a statement. If you don't write this statement, you will lose 1 mark. The statement is, by remainder theorem, when fx is your this polynomial is divided by x minus 1, by remainder theorem, when fx is divided by x minus 1, remainder is equal to f1. Whatever value of x you get, you put it in this polynomial f1. So whatever will be the value of f1, that will be the remainder. Now in your given algebraic expression or the polynomial, substitute the value of x as 1. So I am writing f1 is equal to 2 into 1 cube minus 3 1 square plus 7 into 1 minus 8. Solve it further. 2 into 1 cube will be 2, minus 3 into 1 square will be minus 3, plus 7 into 1, 7, minus 8. And it will become 9 minus 11. That is minus 2. So what is the value of f1? Minus 2. And I told you, remainder is what? In the theorem, remainder is f1. And value of f1 we are getting as minus 2. So it means remainder is minus 2. So when you get the value of f1 as minus 2, after that you are going to write the last step. Therefore remainder is equal to minus 2, whatever is the value of f1. This is what you have to show. How to show the remainder by using remainder theorem. Now your exercise is based on remainder theorem plus the factor theorem. Now if you are going to divide the given polynomial by x minus 1, you are getting a remainder minus 2. Suppose if you do not get any remainder, or in other words your remainder comes out to be 0. If the remainder comes out to be 0, then we say that it is a factor. As for simple example, if I divide 15 by 3, you will say 3 5s are 15. There is no remainder. Remainder is 0. So that is why we say 3 is the factor. So in your algebraic expressions, after putting the value of x, when you find fx, if fx comes out to be 0, then the given divisor means is the factor. But as in this question we are getting the remainder as minus 2. We are getting minus 2. So that is why x minus 1 is not its factor. Now I am going to show you one more question. There you will find that the remainder comes out to be 0. Because the question says Show that x minus 3 is the factor of the given expression. The question is, show that x minus 3 is factor of x cube minus 3x square plus 4x minus 12. So in order to show x minus 3 as the factor of this algebraic expression, we have to show the remainder as 0. Again, not by division, but by using the remainder theorem. So first step, what I told you is to give a name to the algebraic expression. Let fx is equal to x cube minus 3x square plus 4x minus 12. The next step is put your divisor x minus 3 as 0. Value of x comes out to be 3. Then again a statement by remainder theorem. When fx is divided by x minus 3, remainder is equal to put the value of x which we have found, f3. Now we are going to find f3 of the given expression. Substitute the value of 3 in the given algebraic expression. f3 is equal to 3 cube minus 3 square plus 4 into 3 minus 12. So f3 comes out to be 27. 3 cube is 27. 3 square is 9 minus 3 in 27 plus 12. 4 3s are 12 minus 12. So it is 27 minus 27 cancels out, plus 12 minus 12 cancels out. So f3 it comes out to be 0. So what is f3? F3 value of f3 is remainder. Remainder is equal to 0. Therefore, by factor theorem, x minus 3 is factor of fx. If the question says show that it is a factor, in that case you have to show the remainder as 0. But if the question says it is a factor, in that case it means remainder is known to you. That is, remainder is 0. Now I'm going to take many questions are based on remainder theorem. There are different type of questions which are based on this theorem. Now I'm going to take one more questions. In that case, remainder is given to you. Now in these two questions, we have calculated the remainder, and in the second question, we have shown that the given divisor is the factor. For that, we had shown the remainder as 0. Now you get many questions based, as I told you. Now one of the question which I am taking is that remainder is given to you, and you are asked to find the one of the coefficients of the algebraic expression must be missing if the remainder is given to you. Now suppose the algebraic expression is x cube plus 3x square minus kx plus 4, and it is divided by x minus 2. Again you are going to give a name to the algebraic expression. Let fx is equal to x cube plus 3x square minus kx plus 4. Now divisor is given to you as x minus 2. So next step is you are going to put x minus 2 as 0. So x is equal to 2. Now it is also given that the remainder is k. It means value of fx, or in other words, when you put x as 2, remainder will be f2. So f2 is given to you as k. It is not that it will be always given in terms of letter. There may be some constant number also. So whatever is the remainder given to you, we are going to substitute it. So again the statement, by remainder theorem when fx is divided by remainder theorem when fx is divided by x minus 2, remainder is equal to f2. By putting the value of x as 2, f2, and remainder is given to you as k. Now we are going to find f2. f2 is equal to 2 cube. I'm going to substitute the value of x as this, plus 3 2 square minus k into 2 plus 4. Now put the value of f2, which is remainder and given in the question, as k. Put it as k. It will be 8 plus 2 2s are 4, 3 12 minus 2k plus 4. Now you see one of the coefficient of x is given in terms of k, and you have to find this k. If I transpose minus 2k to the left, it will be 3k is equal to, after adding all the other numbers, it will be the 24, and k comes out to be 24 upon 3 as 8. So sometimes you may be asked to find the remainder, sometimes you may be asked to show that it is a factor, sometimes you may be asked to find one of the coefficient. So see this video and try to do some of the questions of the beginning, or at least I think 7 to 8 questions you can do. Then I'm going to take up few other questions in the next video to find out the answers for because many questions are different from each other. That I'll explain later on.